Hello, Assalamualaikum to Madam Anis and to anybody who taken the time by watching our presentation video today. I am Muhammad Farid bin Rizwan from Group 1. Besides me, there are 4 members in this group. So, I'd like to quickly introduce my fellow friends in the order in which they appear in this video. First, we have Muhammad Azan Hilmi bin Karul Amali. And then, we have 2 ladies, Nur Manisah binti Suhaimi and Fatih Nur Ayuni binti Muhammad Noor. And lastly, we have Ahmad Naim bin Abdul Halim. Our given motion today is about moment of a force. So before my friends taking over this video, let me explain first the meaning of moment of a force. Moment of a force, which also known as torque, defined as the turning effect of force applied to a rotational system at a distance from the axis of rotation. The moment is equal to the magnitude of the force multiplied by the perpendicular distance between its line of action and the axis of the rotation. For our case, we chose bicycles for our discussion as it meets the torque requirements. So, in our discussion, there are 4 situations to ride a bicycle. First, riding the bike while sitting on a straight road. Second, riding a bike while standing on a straight road. Third, riding a bike while sitting on a hilly road, and fourth, riding a bike while standing on the hilly road. In this case, we would like to take a test about the moment of a force. So the question is, how many forces needed to ride the bike in the different situations? We assume that the distance is fixed, which is 15 meters. So let's go calculate something.
Okay, I will discuss the first situation. Let's go. Okay guys, from this video, we know there is a young man who ride his bike while sitting on the straight road. He ride it with a stable. If you want to know why, it's because the moment of force. If we are sitting, we use the small force. Small force will produce small momentum. So in this situation, we want to calculate the moment of force. So we assume the force is 10 Newton and the distance is 50 meter. So based on the formula, moment equal to F time distance. So we just input the force and distance. Then we will get the moment of force is 150 Newton meter. That's why the bike will stable. Thank you.
Based on situation 2, riding the bike while standing on a straight road will produce a higher force. To calculate the moment of a force, we use the formula moment equal to F times D, where F is force and D is distance. In this video, we assume that force is 20 Newton and distance is 15 meter. So the total will be 300 Newton meter. We can conclude that a higher force will produce a higher momentum, and the bicycle will not be in a stable condition when we ride it while standing.
Situation 3. Riding a bike while sitting on hilly road. Based on this situation, we would like to take a test about the moment of a force. How many forces needed to ride a bike while sitting on hilly road? So, we will use the formula of moment, which is T equal to F times D, where D is constant, which is 15 meter, and same bicycle is used. So let's calculate. So we assume that the value of F is 15 Newton. So T equal to F times D. So it will be 15 Newton times 15 meter, and the answer is 225 Newton meter. So when we are sitting, we need to use small force. Why? Because small force will produce small momentum and it will make the bike slow.
Situation 4, riding the bike while standing on a hilly road will produce a higher force. To calculate the moment of force, we use the formula moment equal to F time with D, where F is force and D is distance. In this video, we assume that force is 30 Newton and distance is 15 meter. So the total will be 450 Newton meter. We can conclude that the higher force will produce the higher momentum, and it will make the bike fast when we ride it while standing.
So that's it. We have reached the end of the discussions. So many so. Therefore, we can conclude from all the discussions that riding the bike while sitting either on a straight road or a hilly road requires small force compared to riding the bike while standing on a hilly road or straight road that require the rider to use the higher forces. That's it. Thank you.